All right, let's go and get started with section 8.6 notes with slope and rate of change. The objective here is that after this lesson, you should be able to determine the slope of a line. All right, so for this first task, we are using this function rule to complete the table of values. So f of x is equal to 2x plus 3. So again, we've done this already before, so let's go ahead and fill this out real quick. All right, so using the function, we're able to complete the table to find the output values. Part B is asking us, does this table resemble an arithmetic sequence? Yeah, it does, right? Because we see that there is a common difference. To get from one term to the next, we have to add 2. All right, so let's go and review the different forms here, slope-intercept form and point-slope form for a linear function. So slope-intercept form is y equals mx plus b, while point-slope form is y minus y sub 1 equals m parentheses x minus x sub 1. So what is part of both forms? Well, we see definitely there's an x and a y in both equations, right? But they also have another variable in common, and that's the letter m. So you see here in our function equation, f of x equals 2x plus 3, the m value is 2, right? It's in slope-intercept form, and so because it's in slope-intercept form, it's easy to identify the m value. That's 2, right? And it is not a coincidence that that value is the exact same value as the common difference of a positive 2. When we get to the next example here, if you were given the function f of x equals negative 7x plus 4, what is the common difference? Again, we are making the connection that the m value in slope-intercept form is the same value as the common difference. So the m value in this equation, since it's in slope-intercept form, is negative 7, and that is the common difference. So here we have the graph for f of x equals 2x plus 3. Again, it is a line like we're expecting, right? Because, right, the graph for an arithmetic sequence is that of a line. So it says here, find the ratio of the rise over run from 2 different points here. So we're going to start with negative 1, comma 1, and 0, comma 3. All right, so finding the rise and run ratio for those 2 points, here I highlighted that little section of the line. All right, again, the rise, you can see as we go from the point negative 1, 1, we're going to rise 2, and then we're going to run 1. The rise value is 2, so from this point, we're going to go up 2 boxes, and then we're going to run 1 box to the right to get to the point 0, comma 3. So the rise-run ratio is 2 over 1, which we can simplify down to 2. Now we're going to do the same thing here with the point 0, comma 3 to 1, comma 5. Okay, so again, doing the rise-run ratio, again, we're going to see from 0, 3 to 1, 5, we're going to go rise up 2 and then run 1 to the right to get to the point 1, comma 5. So again, the same rise-run ratio for 0, 3 to 1, comma 5. All right, so now we're going to move on to number 3, where we're going from negative 1, 1 to 1, comma 5. Here we're going the full distance from this point, negative 1, 1 to 1, comma 5. So again, the rise-run ratio. So we're going to start with this point down here. So we're going to rise 1, 2, 3, 4. So we got a rise value of 4, and then we're going to run to the right 2 boxes. So the rise of 4 and run of 2 is going to give us our rise-run ratio. So 4 over 2. Right, but as you can see, the rise-run ratio of 4 over 2, we can simplify down to just 2. Okay, so what we're noticing here is that no matter which points that we pick that are on the line to find this rise-run ratio, it's going to be the exact same value. All right, so let's define the slope. So slope of a line is the ratio of the change in the y values over the change in the x values. So now sometimes people like to simplify the definition of slope as kind of the slant of the line. Okay, so again, mathematically, it is the ratio of the change in the y values over the change in the x values. We also want to make sure we have a good idea of, like, when we are looking at a line, right, whether or not we can at least have some already given information regarding slope. Like, for example, if you take a look at the graph to the far left, right, so you see that this graph is increasing from left to right. Right, so with this type of graph, when the graph is increasing from left to right in this manner, right, we should know going forward that the slope is going to be positive. Okay, so we might not know the exact numeric value of the slope for that line, but because in the way that it is rising from left to right, we know that the ratio of the change in y values over the change in x values will lead to a positive value for slope. Conversely, with the next graph to the right of that, as you see that it's decreasing from left to right, right, we should know going forward that no matter what numeric value we calculate for slope, that the sign for that value is going to be negative. So we should have a negative slope value. Now with the next two graphs, right, we see that there is no slant, there is no change. So for a graph like the next one here, where the graph is going straight across horizontal, right, we got to know that this slope value will always be 0. When it's straight horizontal like this, the slope value will be exactly 0. And then with this last graph, can you see that the line is straight up and down vertical? Right, so for a line like this, to determine the slope, we're going to say that the slope is undefined. Okay, and we're going to get to some examples of how we calculate these values and how these outcomes come about in determining the slope. All right, let's take a look at this first graph. So we have two, highlighted points with the big black dots. So we're going to use those points to help us calculate slope. Okay, so we're using those points. So again, we're going to start with this point right here towards the bottom, and we're going to make our way to this point over here to the far right. So again, the slope is the ratio of the change in y over the change in x. It's the rise over run. Whenever we have a graph line, we definitely want to do that rise over run concept. Okay, so I'm going to start at this point, and we're going to go rise up 1, 2, 3, 4 boxes. So I have a rise of 4, and we're going to run to the right 1, 2, 3, 4, 5, 6. All right, so there's our run. So it's rise 4, run 6. And when we simplify that fraction, 4 over 6, it reduces down to 2/3. All right, always want to keep your slope in terms of a fraction, never in terms of a decimal. All right, we move on to part B. Now you notice we don't have the big black dots to highlight here. So again, we want to pick points that are easily identifiable where we can count these nice whole boxes for our rise and run. Now you notice that these points that I picked with the red dots are points that where the line hits the corners of the boxes. Again, I want to be able to count whole boxes from my rise and run. All right, so now again, I'm going to go ahead and do my rise and run. All right, so I'm going to start with the lower point here. And I'm going to rise up 1, 2, 3 boxes. All right, so I rise up, so it's a positive 3. But this time when I run, I'm going to run to the left 1. All right, and because I'm running to the left, that's going to make my run value negative. All right, so when I do my rise of positive 3 and put it over a negative 1, I see that it leads to a negative slope value. which again we're expecting, right? Again, when the graph slants down from left to right on our graph grid, we should know that our slope value is going to be negative, right? Again, going back to part A, because our line is increasing from left to right, we are expecting a positive slope value, and that's what we got here. All right, so moving on to part C. Again, we're going to pick 2 dots here on the line that we can do our rise over run counting of boxes. Okay, so maybe I pick these 2 points here on the line. All right, so now let's do my rise over run. So starting with the bottom point, I'm going to rise up 1, 2, 3, 4 boxes. So for my rise number, it's rise 4. But in terms of a run, I don't need to run sideways because I'm already at my point of destination. So my run number is going to be 0. Again, my rise number is 4 and my run number is 0. So my rise over run is going to be 4 over 0. Now again, let's think back to our earlier math days here, right? 4 divided by 0. Remember that fraction bar works as a division. 4 divided by 0, hey, we can't do that. That's why for this one, we talked about before, a straight up vertical line is going to have a slope that is undefined. Undefined slope. Now moving on to part D, again, we're going to pick 2 points that are on the line. It doesn't matter which 2 points you pick to determine slope. Just pick 2 points that you can easily count boxes. So now I'm going to do my rise over run. So I'm going to start with this point right here. Now, I don't have to rise anywhere, right? I don't have to go up or down. So my rise value is 0. And my run is going to be 1, 2, 3, 4, 5, 6. So I got a rise value of 0 and a run value of 6. And when I put that in a ratio of 0 over 6, that equals 0. So again, a straight across horizontal line will always have a slope value of 0. All right, so now let's go through a few examples where we're not given the graph, but we are given 2 points that lie on a line. So to find the slope, right, when you're given 2 points, we're going to have to use a slope formula. All right, so again, here is the formula for slope that you're going to use whenever you're given 2 points that lie on a line and you don't have the graph. All right, so m equals y2 minus y1 over x2 minus x1. So we're going to go to example A and show you how exactly you use this formula for slope. So you're going to start off by labeling your numbers in your ordered pairs. Right, so this first ordered pair, we're going to do x1, y1, and the second ordered pair, we're going to do here x2, y2. All right, so once you label your values for your ordered pairs, then you know exactly which numbers are going to go into the formula. Right, so we know exactly where to plug these numbers in. So y2 minus y1, so for us it's going to be -1 minus 2, x2 minus x1, 4 minus 5 in the bottom. So we're going to go ahead and evaluate both the numerator and denominator and simplify our fractions if we need to. All right, and we get a slope value of +3. All right, let's move on to example part B. All right, so we're going to label our numbers in our ordered pairs. And then we're going to go ahead and plug them into the formula for slope. Now, you need to be careful here in situations where either your y1 or your x1 value is negative. So again, we're subtracting in this formula. So down here where the x's are, I got a 4 minus a -2 that we need to be careful and evaluate. All right, so when we do that properly, we get a slope value of 1/2 when it's all said and done. Now we need to be able to make adjustments when our information is given in a slightly different way. So here we're given f of -3 equals -5 and f of -7 equals -17, and we want to find the slope of the line. Well, if you recall, what's in the parentheses are going to be our x values, and the value of f is going to be our output or our y values. Okay, so for this problem, we're going to go ahead and label the x1 and y1 and x2 and y2. And then plug these into the formula. All right, so when we simplify that, we get a slope value of +3. All right, so we're going to stop there for today's video. Go ahead and start working on the 8-6 homework.